Less than 7 minutes. That's how long it would take an Iranian missile to reach Tel Aviv Sena, Aviv. When the Fatah 1 was unveiled in 2023, many analysts dismissed it as propaganda. But after the missile escalations in 2025, it became clear that the weapon was designed to challenge defense systems like the Iron Dome. The concern was so great that the Pentagon initiated a technological race, investing over $20 billion in hypersonic programs, including the ARRW and defense projects like the Golden Dome. But before we begin, don't forget to like and subscribe to our channel. The Fatah 1 is about 12 meters long, weighs approximately 4,500 kilograms, and has an estimated range of 1,400 kilometers, enough to reach any major city in Israel and several American bases in the Middle East. What truly makes it dangerous is its speed. Mach 15, about 18,500 kilometers per hour, or approximately 5 kilometers per second. At this speed, friction with the air creates a layer of plasma around the missile, which can reduce its detection by radar. Furthermore, unlike a traditional ballistic missile, the Fatah has an engine in the warhead itself that is activated in the final phase of flight. For about 50 seconds, it allows lateral maneuvers at hypersonic speeds, deviating from the predictable trajectory. This creates a major challenge for anti-missile systems as the warhead moves within a cone of uncertainty, drastically reducing the reaction time of defenses. In a scenario where seconds decide everything, weapons like this are changing the speed and logic of modern warfare. When an Arrow 3 or David's interceptor sling is launched, and Fatah may have already altered its trajectory several times. And for those who thought it was just a prototype, by early 2026, data from real-world confrontations tell a different story. Analysts suggest that, in saturation attacks, at least 1 in 10 of these high-speed warheads can penetrate even the densest defense networks. When each Israeli interceptor costs more than $2 million, and the Fatah is produced in mass production facilities in the Iranian desert, the mathematics of war begin to shift in Tehran's favor. What makes it so frightening, after all? You might be wondering, don't intercontinental ballistic missiles, ICBMs, that reach Mach 20 already exist? The answer is yes, but an ICBM is like a freight train on a fixed track. Once launched, the laws of orbital mechanics determine exactly where it will fall. If you know the starting point and the speed, you can calculate the destination and intercept it. That's why systems like Arrow 3 and THAAD have been so successful in the past. Fatah changes the geometry of the battlefield. It operates on a trajectory called a depressed trajectory. Instead of soaring very high, it remains lower in the atmosphere, gliding close to the edge of space, like a stone skipping across the surface of a lake. Because it can maneuver at those altitudes, there is no predictable point of impact until the final seconds of flight. This creates a cone of uncertainty that extends for hundreds of kilometers. A defender isn't just trying to hit one bullet with another bullet. He's trying to hit a bullet that is actively deflecting. But the real terror lies not only in the speed, but in the timing. This missile achieved operational status just as the International Atomic Energy Agency, the IAEA, warned that Iran's uranium enrichment had reached 83.7%, very close to the 90% required for a nuclear warhead. When the June 2025 war began, the world realized that Fatah was not just a conventional weapon. It is also a potential delivery vector for a nuclear future. Strategically, this is a masterstroke of psychological warfare. The message to Israel is clear. Its multi-billion-dollar defense system may no longer be enough. Each Israeli Arrow 3 interceptor costs about $3 million. A single battery of the THAAD system is worth almost $1 billion. By launching salvos of mass-produced Fatah missiles, Iran could, in theory, deplete a country's defense budget in a single night of combat. This isn't just a technological race, it's a race of attrition. And within a window of just 400 seconds, there's no room for hesitation. The United States' response? ARAWW, HALO, and LRHW. While Iran perfected Fatah, the United States realized it was falling behind in the hypersonic race. In the 2026 fiscal budget, the Pentagon requested over $3.9 billion for research in this area alone, part of a broader investment of approximately $180 billion in research and development. The United States is attempting to catch up with three main systems. The first is the AGM-183A, known as the Air-Launched Rapid Response Weapon. This is a missile weighing approximately 3,000 kilograms and measuring about 6.7 meters in length. After several uncertain funding cycles, the 2026 budget includes $387 million to begin its acquisition. The RRW was designed for extreme speed. It climbs to high altitude before releasing a glide vehicle that can reach Mach 20, approximately 24,000 kilometers per hour. With a unit cost between $15 million and $18 million, the plan is to equip B-52 bombers with these weapons, capable of carrying up to 31 hypersonic weapons using new specialized mounts. Then there's DARK, the U.S. Army Eagle, officially called the Long-Range Hypersonic Weapon. This is a huge truck-launched system with a range of approximately 3,500 kilometers. It uses a large-diameter propellant to launch what is known as a conventional hypersonic hoverbody. The Dark Eagle can hit a target about 3,000 kilometers away in less than 20 minutes. In the 2026 budget, the Army requested $354 million to acquire the first three complete missiles, each costing approximately $41 million. Finally, the Air Force is betting on hypersonic attack cruise missile, Sedan-2, or HACM. Unlike the Fatah, which functions as a hypersonic glider in its final phase, the HACM uses a scramjet engine developed by Northrop Grumman Secton. This allows it to maintain speeds close to Mach 8 over a range of approximately 1,100 kilometers, flying at lower altitudes and making it more difficult to detect by radar. The 2026 budget allocated $803 million solely for the development of the HACM, with the goal of integrating it into the F-15E strike fighters. Eagle until 2027. But the most expensive item isn't a missile. It's the so-called Golden Dome. The United States has committed approximately $15 million, $7 billion to a space-based tracking layer. This includes the hypersonic system and ballistic tracking space sensor, a constellation of satellites designed to detect the faint thermal signatures of maneuvering missiles from launch to impact. Added to the Glide Phase Interceptor, a program that Northrop Grumman is developing under an $832 million contract, the true scale of this race becomes clear. The United States isn't just building faster missiles, it's spending hundreds of billions to create a network capable of intercepting them. Real capability or just well-crafted propaganda? Iran has a long history of exaggerated military optimism. In the past, we've seen stealth fighters that turned out to be just fiberglass mock-ups and announcements of quantum computers that in practice were just low-cost commercial motherboards. So, would Fatah be just another example of this technological showcase? In early 2026, the answer is complex. Analysts from the IISS and CSIS point out that Fatah 1 is not a true hypersonic hovercraft like the Russian Avangard or the Chinese DF-17. These systems are essentially gliders that travel thousands of kilometers in the upper atmosphere. The Fatah, on the other hand, appears to be a highly sophisticated evolution of the Fateh 110 family, the same lineage of solid fuel missiles that has been the mainstay of the Iranian arsenal for 2 decades. Basically, Iran took the proven structure of the Fateh 3.10, shortened the missile body, and replaced the standard warhead with a maneuverable re-entry vehicle equipped with its own rocket motor. Western skeptics initially argued that a true hypersonic missile would need to maneuver above Mach 5 throughout its flight. The Fatah likely only reaches its stated speed of Mach 15 during a brief final sprint toward its target. For about 90% of its flight, it behaves like a conventional ballistic missile, and ballistic missiles can be tracked by advanced radar. However, the propaganda argument suffered a setback during the missile exchanges at the end of 2025. Nevatim Air Base confirmed the presence of a thrust vectoring nozzle that had clearly been subjected to intense thermal stress. Israeli defense reports acknowledged that, although the Arrow 3 system had an interception rate between 80% and 90%, approximately 36 Iranian missiles managed to penetrate the defenses during the 12-day conflict. This is where propaganda transforms into a strategic stance. Even if Fatah is only half as capable as Tehran claims, it has already achieved its main objective: strategic ambiguity. By forcing the United States and Israel to assume the worst possible scenario, Iran has managed to alter the defensive posture of the entire region. Israel is now racing to accelerate the development of Arrow 4 and Skysonic, systems specifically designed to deal with unpredictable targets. When you force your opponent to spend $3 billion on a new shield just to neutralize a missile worth about $1 million, you've already won the economic war, even if your missile never hits its target. Iran has just joined the hypersonic club. Whether it's real, a bluff, or something in between, it's forcing the United States to spend billions, prepare interceptors, and react quickly. Because when a missile claims to be able to overcome any defense in 7 minutes, nobody waits to find out if it's a bluff. So click subscribe so you don't miss the next shockwave. Until next time.